Hey everyone, this is Hamilton Payne, and today I have another video covering Physics 2212 and the test that we took. This was test 3. Let me just pull it up here. So this is my test. We have the crowd mark scores. Say the mean was 90.5, so it was really good. And I also did very well. I only missed 1 point. So for this, I'm just going to cover the part that I missed, where I missed a 1 point. That was actually a unit issue. A lot of these were decently difficult. Well, could be potentially confusing for people, but I spent a lot of time studying this time. I studied a lot better, and so I was more productive beforehand before I took the test, and that helped me in the long run as well. I definitely don't think if I had studied a couple hours less, I would have done as well. So what we have here, this question was about flux, and actually the interesting thing about it, the most interesting thing is that for flux on the x-axis, it was actually proportional to the x value. For this, the first part was really simple. I probably spent too much time doing it. As you can see, um, I go through all these equations. It just says, for this first part, it actually didn't have the x value, so it wasn't proportional. So the flux wasn't changing along the x-axis. This one, it was just uniform. And since all of it's passing through, the negative fluxes add up with the positive fluxes, and it equals 0, as you can see here. So the electric field, according to the question, the electric field at all locations on each surface of the box is found to have the value E, and then if I zoom in, there's this vector right here, negative 100, 500, 100. So it was just simple. Calculate E of Y, E of X, E of Z. Go through all of them. Make sure that on each part of the box, left, right, front, back, up, down, top, bottom, that everything's 0. And so if everything is 0, that means there can't be any charge inside the box. So this part, I spent a lot of time on it, but it was decently easy because everything added up to 0, and just my explanation was that the electric field passes through all of it, so all the pairs, the surface pairs of the top to bottom, up, down, one is positive, one is negative, they both have the same magnitude, therefore it ends up the electric flux is 0. So this one is the next part of problem 4, part B, is where the x value of the electric field is proportional to the x value along the axis, to the position. So the thing about that is that the E of Y and E of Z were simple enough because they stayed at 0, but the E of X was different. And so I actually got a flux that was negative, and when I used Gauss's law, so that electric flux equals Q over E naught, I got this value right here. So here's what I missed. As you can see, it says I have negative 1 point for missing the units. I thought I had checked to make sure everything had units on it. I went back through my test. This was mostly just a careless error. The question itself I might have spent too much time focusing on other things, such as going through these calculations, where I could have probably done most in my head, but it's always good to do this on tests to make sure that if you do miss things for careless errors, you get points. This one, I forgot to put coulombs. Charge measured in coulombs as the SI unit, it was negative. So I actually got the value right. It's just that I didn't put it in the proper units, and that's important when you're doing physics. In fact, it's important when you're doing any type of calculation and any type of science. Because you got to know what it's referring to, what that value is referring to. You can't just have a unit value. So my explanation was that Q was not equal to 0. And the explanation was right. The calculations were right. All the parts of this question, I got them right. I didn't miss anything except the unit. And so I hope that if anyone sees this, maybe other students, probably not, they're probably just going to submit their own videos, but they know that they need to be consistent about this, always checking to make sure that they have the right units. Other than that, the test, I guess I did everything right for the test. I was very systematic about it. As you can see, I have my own steps being detailed, so that was a strength for me. The units, I missed a couple for there. Like I went back and I had to write the volts for this. I didn't have that at first. And maybe it's a bad thing. Maybe I need to get into the habit of writing the units the first time. Additionally, I probably didn't have it for these either. I just added meters a second, volts over meters, stuff like that. So, that being said, that's all I have to share today. Make sure you put your units in. It was really good that I did well on the test. Thank you so much for watching, and peace.